Hey there, fellow navigators. We got the locomotive pretty well torn apart here to do our annual inspection, and show you some of what we found. We took the valves out, took the heads off, take a look in the cylinders, of course the crossheads off, and generally we didn't find too many problems. Everything looks pretty good in the bores. Cylinder looks all right. You can definitely tell the locomotive is worn out. Look how much of a gap we have up there. At some point it probably could use new pistons, but well, for what we're doing with it, it's not too terribly bad yet. But we'll watch that. We got all the piping and all that taken apart, and everything dried out. Let's take a look here. Got the grates out. You can take a look down in there and see what it looks like underneath the grate level. So that there is the drawbar. It swings back and forth, and then we just have the holes, and then it just goes right down to the ties. Then you can see the rear drivers there as well. So one of the things we're going to be working on is we're going to change the position of this valve here. It's kind of hard to get to up in here. And this is a pretty hard valve to turn. So I'm going to take this one here and we're going to mount it so that it's out here. So this will, I'm going to reorient the piping a little bit on that. We're going to work on getting another throttle assembly made over the winter. I mean, this one here is got all sorts of play in it, and that's original. So I'm going to remake a lot of this and hopefully get rid of a lot of that lost motion. And show you what we got going on this side here. We did the same thing on this side. Pretty much tore it down. When I put the locomotive together a couple years ago, I used it's just silicone RTV because I didn't have the copper gaskets that go in here. So we'll see about getting proper gaskets made for it this time when we go to put it back together. Definitely works better than the RTV. Again, this side here, no problem in the bores. Everything looks good. However, we had that problem with the engine having the offbeat exhaust, and we found something here that might explain it. I'll go in the other building and I'll show you. All right. Well, what we have here, these are all the parts off of the right side of the locomotive. And this is the piston valve spool. And when we took this apart, now this is the stack of components. And on the piston valve, you have a cover plate, a ring, then you have a center section, another ring, and then another cover plate. And they all fit together. And so here's the other one. So you have this plate. There's the cover plate. There's a little pin that fits in that hole, so that orients that. There's another pin here that the ring sits in, so the ring can't move around. Then you have another pin there, and that ring sits in there. And then this fits on top of that. And then that's on the inside, that fits up against there. So if we take all of these components, flip them around, and this one here, if I can get that pin in there right, I don't think I can, but at any rate, when this was together, there was quite a bit of a gap, and it was like that when we took it apart, a big gap in there. Well, if you take this piece, it's just supposed to be dead flat. You set it on a plate, this isn't flat anymore. It's bent back. So it's bent back enough to give that ring a lot of slop in there, and then there's way too much clearance, and that allows the steam to just pass by that ring, pass by the other ring, and you're basically not developing your full steam pressure in that end of the cylinder. So the question is, did I overlook this when I originally put it together, and was that thing bent to begin with, or did something happen while we were running that bent that, which I don't know. I mean, we only started noticing this once we started going uphill in the forward direction with the new track in. Previously, all the forward motion had been going downhill, so is that going to play into it any? That and we're not hearing the offbeat exhaust going backwards. It was only going forward. So might this have been like this to begin with? Did I overlook that when I put this together originally, or did something happen? I don't know. There's no damage in the bore. You know, there's nothing where like something got in there and got caught. One of our crew members suggested, well, maybe water. You know, was carrying water, got a slug of water in there, and that could have bent it. Yeah, that's entirely possible too. So regardless, whatever caused that, I do have a spare piston valve that we saved out of the 59 when it was scrapped. So I'm going to see if I can take this part off of that other set and replace this here, and just not use this anymore. And that'll save us a little bit of money over making another one of these. So if it'll fit, then I might use it. Otherwise, I'll have another one of those made. Yeah, I mean, we didn't tear this apart last winter to take a look at it in the off season. So this is basically the first full year of running, and then running this past summer, and then taking a look at how things look. And I tell you what, other than that problem with that one part there, I'm not really seeing any issues here. I mean, everything else is holding together just fine. I've no other surprises. I'm very well pleased with how the locomotive's been operating. We do have a couple other things we're planning on doing over the winter. We've got these slippers that go on the top and bottom of the crosshead. These are made out of cast iron. We're going to make new ones out of a material called nylitron, which is a nylon that's impregnated with some sort of, there's some special material that's designed for wear applications, and it's made out of plastic. So we're going to make the new slippers out of nylitron. What also that means is that we won't have to lubricate the slippers anymore. And actually, you're not supposed to lubricate that. It works better if it runs dry. So we're going to see how well that works. I think that'll wear a lot better than cast iron on steel. All right, so looking at the front of the locomotive here, one of the other things we're going to look into over the winter is with the new tender and the German flat cars that we're going to have. So we're going to have a larger tender, hopefully I'll get built over the winter, and then two flat cars, one of which will become a passenger car, and who knows what we're going to use the third one for yet. Well, all those cars had couplers like this, and this is a German 2-foot gauge coupler, and basically it's just buffers, and then you have a hook on one side and a chain on the other, and you just hook chains together, and your draft forces go through the chains, and your buff forces through the central buffer. So I plan to use those on these large German cars, and then also put those couplers on the rear end of the tender on 58, and then also on the front end of the locomotive here, if we ever get in a position where we're going to be moving those cars from the front end. So trying to figure out some way that maybe we can adapt that coupler to go on the front of the locomotive here in a way that would be usable, so we could still use the Lincoln pin, or make it as a something that can be put on and removed if need be. Just trying to figure all this stuff out. But one other idea we had was, well, we just leave the locomotive as link and pin, and take one of the four-wheeled Carpenter cars and then put the German coupler on the end of the Carpenter car. And by doing that, it would be a transition or idler car. And on these steel mills, you saw a lot of that. You'd have the locomotive, you'd have this little four-wheel idler car, and then you'd have your ingot mold buggies or whatever. So that would be sticking a prototype if we did that on this. So that might be a way of getting around a problem. The reason I want to go to these couplers here is because they're so simple, and they're a lot safer than the link and pin, which, you know, you've got to bring the equipment up close, and you got to get everything lined up just perfectly, and then put the pin in, and you have to have people in between cars and all that. I mean, this thing here, you just push up against the car you want to couple on to, stop, and then drape two chains over, and you're ready to go. I mean, it's a lot better design. Unfortunately, they're gigantic for the size of our equipment, but we've got 8 or 9 sets of them that we can work with. So there's enough there to put couplers on everything I'd like to have these couplers on. So I don't remember if I showed you these in a previous video or not, but these are the four-wheeled trucks, German trucks that came from the Heston Steam Museum. Of the 3 cars that we're getting, these trucks are smaller than the trucks that were on the other 2 cars, and which is good for us because this is the right size to use for a tender. Now, of course, you know, we don't have a lot of clearance on the bottom of that of the locomotive, and we don't want the deck of the tender to be much higher than the deck of the cab. So if you push this up close, you can see that these trucks are about 2 inches lower than the deck of the locomotive. Well, traditional construction of cars, I mean, that would be a problem because you'd have your center bowl, and then you'd have your center cell, and you'd have 8 or 9 inches above this to get to the deck level. But we're going to do things a little bit different. I think on this tender, we're going to get a piece of 3/4 inch steel plate and use the steel plate as the deck of the car, and then machine a piece that fits in here, and which also fits into the steel plate, and then weld it up, and then the plate sits on top here, just clears the side bearings by, you know, 1/8 of an inch or so, and then that basically makes the frame of the car only about 3/4 inch thick. So we can have that deck real close to the trucks. And the 3/4 inch plate, 68 inch wide, 14 feet long, albeit expensive to buy, is going to be more than strong enough for what we need to do. And we can still add the channel on the outside hanging down that, you know, to form the outside frame of the car. And in doing this, you won't see much of the trucks of the tender. It'll kind of sit real low, but it'll be a way that we can retrofit this very, you know, low deck locomotive to having a standard style tender. You know, as this tender here, we're going to keep it around even once we get the longer one done. And the longer tender is only going to be 3 feet longer than this one here. It'll look twice as big, but it'll just be a little bit longer. And this one here we're going to keep around, especially for when we bring one of the Canadian porters back and restore one of those operations someday. Then this tender can then go with that locomotive. But for something that we're going to run every day in passenger service, I'd like to have a much better tender. That, you know, these are, I mean, all 4 wheels are independently equalized, leaf springs. I mean, these are lovely, lovely trucks, and I'm glad that I got them. And having the, you know, having the better trucks here means that the tender's going to track a lot better, less chance of a derailment. Better ride. I mean, it's just better all the way around. I have a much larger and more functional tender. So that's all we got going on right now. And as we go through the winter, we're going to be doing some work on the locomotive, putting it back together and making some of the new parts and all that. Of course, I will do some video updates as we go to let you know what's going on with the locomotive, and as we go through the annual inspection and get things ready for next year. So well, we'll talk with you later on, and thanks for your support.